If a voltage higher than the breakdown voltage is applied between drain and source, the current will flow even in the off state. This state is called avalanche breakdown. Since this is a condition that exceeds the breakdown voltage, it is preferable not to enter the avalanche state if possible. But there are some devices that guarantee avalanche breakdown under certain conditions, such as the amount of current and energy. In a circuit in which a MOSFET is connected to a device with a large inductance component, such as a solenoid or transformer, the energy stored in the inductance at the moment of turning off charges the drain source of the MOSFET, so avalanche breakdown easily occurs. This illustration explains the mechanism of avalanche breakdown that occurs when the L load, or inductive load, is turned off. Current flows through L in the MOSFET when voltage is applied between gate and source. The MOSFET is in the on state, so current is flowing through the channel. Energy remains in L after the MOSFET turns off, so current still flows even though the MOSFET is in the off state. However, since the channel has already disappeared, this current is charging the drain source capacitance COSS. When COSS is charged and VDS exceeds the withstand voltage VDSS, avalanche breakdown occurs and current flows between drain to source even though it is in the off state. Since the MOSFET is already turned off, this current does not flow through the channel as it would in the normal on state. Let's review a breakdown of all the processes over time. In the first step, the MOSFET turns on. In this state, VDS is nothing because the current goes through. This current is large and increasing. The second step is when the MOSFET is turning off. In this state, VDS surges up and the current is gradually going down. The channel on the P layer is disappearing if overvoltage is applied, and the MOSFET would go into the avalanche breakdown state. The third step is when the MOSFET is completely off. If overvoltage is applied, the current is still there even if the P layer disappeared. In this case, we must have a big loss at the P layer. In the fourth step, the current completely disappears and VDS is also mitigated. In the fifth step, this is just a symptom for the inductor whose energy comes and goes between the inductor and the MOSFET. As the breakdown occurs in the diode by overvoltage, the p-n junction of body diode between the drain to source allows current to flow in the breakdown state. In this case, a very large power loss occurs because the current is flowing between drain to source while a large voltage is being applied. The current gradually decreases, and when the energy remaining in L disappears, the current becomes zero and the avalanche state ends. Then VDS converges on the power supply voltage VDD, while the current oscillates between L and COSS.